Hey everyone, welcome to Linux Command Line for Beginners. In this course, you're going to learn everything you need to know about the Linux command line, from the basics to more advanced concepts. So by the end of this course, you'll be able to fully navigate around the command line with confidence. If you're looking for a comprehensive, easy to follow and well-organized course that takes you from zero to hero, you're in the right place. You don't need any prior knowledge of Linux or the command line. Everything you need to know is in one place, so you don't need to jump back and forth between random tutorials. If you're new to the channel, be sure to subscribe because I plan to upload more content like this in the future. All right, let's get started. In this lesson, we're just going to be getting our feet wet with the command line and learning a couple of commands. So right now I'm running a program called the terminal, and the terminal runs what's called a shell. And a shell is a tool you can write commands for the operating system to run. So you write your command, you press enter. As you can see, it says command not found because this is not a command the shell recognizes. So if we want, we can type something like date, and this prints out the current time and date. So you might be asking, how do I know what the commands are? Honestly, this just comes with practice. There are certain commands that you're going to be using all the time. There are going to be certain commands you're going to have to look up. There might be things that you want to do where there is no command for, and you're going to have to write your own script to do that. But that's further down the line. So let's talk about this line here. So first we have Sam, and this is the username. And then you have @ and then the host machine. So my host machine is called sam-virtualbox. And then we have this colon here, which is just a separator. We have this tilde, which marks the current working directory. If you don't know what that means, don't worry about it. We're going to actually cover that in the next lesson. Then you have this $sign here, and this just denotes that this is the beginning of where you can start typing. So let's run a couple of commands. So we already ran the date command. There's also df, which shows the amount of free space on our disk drives. There's also free, which shows the amount of free memory. So this virtual machine has 4 gigabytes of RAM. And as you can see here, it has 4 million kilobytes, so 4 gigabytes. And then finally we have exit, which, as you guessed it, exits the command line. So one last thing I wanted to go over is the command history. So if we want to go back to, like, say 3 commands ago, so say we want to run the date command again, we could just run date. Or what we can do is we can press up on the arrow key, and this shows us our command history. So say you wrote out a really long command and you don't want to write that whole thing out again, you can just push up and it goes back to that command. And if you push down on the arrow key, then it moves forward. So that's the command history. Most Linux distributions remember the last 1,000 commands by default. All right, that's pretty much it for this first lesson. As you can see, it's not as scary as you might have thought. In the next lesson, we're going to learn a few more commands and learn more about the Linux file system. So I'll see you then. In this lesson, we're going to be learning about the Linux file system, as well as learning 3 new commands, which are probably the 3 most commands that you're going to be using, but luckily they're pretty easy to understand. So how the Linux file system works is it's a tree-like structure. So you have your root directory, which is denoted by a /, and that directory will have its own subdirectories or files. One thing to note is if you're a Windows or Mac users, you might refer to these as folders. But in Linux, they're called directories. Now, if you accidentally call it a folder, it's not the end of the world, but just know that the official term is a directory. So any directory can have as many directories or files as it wants. And one thing to note is that the root directory will have a home directory, and each user will have its own directory inside the home directory. And each of these directories will have its own set of directories like downloads, desktop, pictures, etc. So the commands that we're going to be learning are how to navigate within this file system using the command line interface. When you open your terminal, you're always going to be on a current working directory. It's the same thing as if I go to the graphical user interface of my files. We see it opens up in the home directory. Except with the command line, you can do so much more. If we want to see what our current working directory is, we can use the command pwd, which stands for print working directory. And this shows the entire path of where we currently are. So there's the root folder, home/sam. If we want to see what the contents of our current working directory are, we type ls. If we want to change the working directory that we're in, we use the command cd. So let's say we want to go to our documents folder. We can do something like cd/home/sam/documents. And if we press ls, we see we don't get anything because there's nothing in this directory. Let's create a file here. Let's call it test. And then if we type ls, we see that we have test in there. So let's go back to our home directory. And a shortcut to do this is just to simply type cd. So up here we saw that we typed the entire path here. This is called the absolute path. It starts from the root directory all the way to where we want to go. But we can also have relative path names, which are relative to the current working directory. So if we type ls and we want to go to documents, we don't have to type the whole thing out. We can simply type documents. Now, one thing to note here, which is something that I said we'd talk about later on, is note that this right here in blue changed. And this is going to be telling us where our current working directory is. So the tilde is always going to refer to our home directory. So it's going to be our home directory / documents. Now, if we want to go back up one directory, how that would work is we would type cd and then ... So this is going to take us back to our home directory. And you can even do something like, let's go back into our documents. If we want to go up 2 folders, you would do cd ... /... This is saying, hey, I want to go up 1 folder, and then I want to go up another folder. So if we do pwd, we see we're in the home folder. Now, a bonus command here is, say we want to clear all this out here and start from the top, we would just type clear, and it clears everything out, and we start back fresh at the top. Another little shortcut thing is we can use tab to autocomplete. Let's say we're in the SAM folder, and we want to go to documents. Well, what we can do is we can do cd doc, and if we don't want to type the rest out, we simply press tab, and then it knows to autocomplete that. Now, if we have something like do, this could be documents or downloads. So if we push tab, it's not going to know what to do. If we press tab again, it'll say, hey, there are 2 things here that match what you want. Which one do you want? It says, oh, we want documents. Okay. All right. So in this lesson, we learned about pwd, which prints our current working directory. We learned about ls, which lists the files or directories within that directory. And we learned about cd, which changes the directory, which we can do either with an absolute path or a relative path. In this lesson, we're going to be taking a further look into the ls command. We're going to look at 2 new commands, and we're going to talk a little bit more about the Linux system. So right now I'm in my home/SAM directory. So we know ls, right? Besides the current working directory, you can also specify the directory to list. So ls/usr. And you can even specify multiple directories. So you could do something like ls and then tilde. Remember, this refers to our home directory, and then user. And as we see here, it lists the contents of the SAM directory, and then it lists the contents of the user directory. So now I want to talk about a very important concept, and that's called options. So most commands allow you to add an option that modifies the behavior in some way. And how that looks like is you type dash and then whatever option that you want. So ls has -l, which stands for long format, and it gives us a little bit more information about all the contents in the directory. You can also have multiple options. So -l-a, which lists all the contents in the directory. You can write these out separately, or you can just use 1 dash and then type la. So as we see here, it prints out everything in the directory, as well as all these additional files that we haven't seen before. So in Linux, if something has a dot or a period before it, this is called a hidden file. You can also have hidden directories. So hidden files and directories will not show up with the ls command. It's the same as if we want to look at the GUI. As we see here, we just see the non-hidden files. If we go here and we check show hidden files, we see that all those files are here. So let's clear that out. So we have commands, we have options, we also have arguments, which is what we've been using. So we want to look at a particular directory. So we have command, option, and argument. You may also see what are called long options. So you could do something like ls-r, which reverses the order, or you can do ls-, reverse. And this does the exact same thing, but it's just written in a different way. So let's clear that out. I want to take a look at this ls-l option. So as we see here, so right now we only have directories. I want to create a file. So I realized in the last lesson I used this touch command, but I didn't explain what it did, but you probably figured it out. It just creates a file. So let's just call this text. Okay, so as you notice here, we have a bunch of stuff that we haven't seen before. So this part right here, these are access rights to the file. So not every user can access every file in the Linux system. You'll have certain users that can only read a file or only write to a file or only execute a file. Those permissions are specified right here. Next to that are the number of hard links or symbolic links. We're going to talk about that in a minute here. Then you have the owner of the file. You have the group that owns the file. In Linux, you can have groups with one or more users in it. You have the size of the file, the date and the time of the file's last modification, and then of course, the name of the file. So one thing to notice here is on the access rights to the file, you notice you have this D here, and then, or you can have a blank here. So this just determines the type of file that you have. So this text here is just a regular file, so there's nothing there. Videos here is a directory. So that's why you see a directory, or you see a D right here. So in Linux, a directory is actually considered a file, but it's a special type of file, and it's denoted by the D here. Of course, the color is different as well, but not all terminals will have these things nicely highlighted for you. Like in older versions of Linux, everything was just in black and white. Of course, for files, we can have different file types, right? You can have something like a text file or a JPEG file. If we want to see a file's type, well, I'm going to cd into my pictures directory, ls. So I added this picture.jpg here. So we can use the file command followed by the file name to show us a little bit more information about the file. And as we see here, it's a JPEG image data with a bunch of other information in here. So as I mentioned, everything in Linux is a file, but you can have different file types, and you can use the file command to get a little bit more information about that file. Now you might also be saying, what's the point of the file command if I can just look at the file extension here and see that it's a JPEG? Well, in Linux, the file extension it's actually not required. So if we want to remove the JPEG, and I'm going to use a command we haven't learned yet, don't worry about it. I'm just going to rename it to picture. Well, now we don't know that it's a JPEG, and we're going to have to use file picture to see that it's a JPEG image data. Next, we're going to learn about the less command, which is a program to view text files. So of course, Linux contains many files that have human readable text. So you could have something like a configuration file that you need to read, or you have a script that you want to update. You use less than the name of the file name. For example, let's take a look at less etc/password. So if the file is longer than one page, we can scroll up and down. So you can press enter to go down a line. You can hit spacebar to go down an entire page. And if you want to go to the end here, then you just press Q to go back. Now, if you try to read a file that's like a binary file, you can, but you're going to get a bunch of gibberish. So if we try to do bin/ls, it says it may be a binary file. Do you want to see it anyways? Yes. And then you get a bunch of gibberish. If you ever get stuck in a page like this, again, just press Q to go back. So at this point, I recommend taking some time and just kind of exploring the Linux file system. You now have all the tools that you need. Press ls to look at all the binary commands. There's some interesting stuff in here. So if you look and you see ls here, this is the same thing this is the ls command that we've been using. So, it's not magic. When you use ls, it goes to the binary folder and it runs this command that's on your system. So if we ls the root directory, take some time to look around here. Since you're not logged in as the super user, you can't mess anything up. You don't have the permissions to. There might be some things that you can't look up, like if you try to cd into the root directory. So if we go back and cd into the root directory, we see that it says permission denied. So if you're logged in as a regular user, you can really only edit what's in your user's home folder. But anything above that, that's usually reserved for like a system admin or a super user. Let's talk about symbolic links. So I'm going to cd into our bin folder. I'm going to ls with the long format option. So let's scroll up here. So if we look at this line here, this is a symbolic link. And how do we know that? Well, if we look at the first character here, we see that there's not a dash and there's not a D. There's a third character we can see here, which is L, which stands for link. And we also see that we have Python 3 and then an arrow and then Python 3.10. And as we see here, we see a lot of different symbolic links, but let's focus on this one. So why would we ever want this? Well, let's say we have hundreds of scripts that use Python. So if those scripts all had Python 3.10, if we ever wanted to update to 3.11, then we'd have to go and change every single script, which is not, doesn't sound like a lot of fun. But what we could do is all those scripts can use Python 3. So now if we ever wanted to update to 3.11, we would just change this symbolic link to now point to Python 3.11, but those scripts can still have Python 3 in them. And that way we don't have to update any scripts and they can all use the new version. We'll learn how to create the symbolic links later. In this lesson, we're going to learn about manipulating files and directories. We're going to learn how to copy files and directories. We're going to learn how to move and rename them. We're going to create directories, remove them, and create links. We're also going to talk about wildcards. So obviously a lot to go over here. Let's begin. So I'm in my home directory. If we want to create a directory, we use the mkdir, the mkdir command, followed by the name of the directory. So now we see we have dir1. You can also create multiple directories at the same time. So we'll do dir2, dir3. And then as we see here, we have dir2 and dir3. We can also copy files and directories using the cp command. So we do cp followed by the first item. We'll just say text and then where we want to copy it to. So let's copy this into dir1. So if we ls dir1, we see that text is copied into this directory. Now, if we want to copy a directory into another directory, we can use the cp command, but we have to use an option here, -r. So if we try to copy dir1 into dir2, so if we try to do this without the option, it's going to give us an error here. So if we try it with -r and we ls, so if we want to cd into dir2, if we ls, we see we have that dir1 in there. And then if we want to list out the contents, we see that text file is still in there. One warning here is if you try to copy a file into another directory and a file with that same name exists, it will overwrite it without any warning. So if we go back to our home directory, so let's cd into sam, let's clear that out. So if we ls, if we do cp-r dir1 into dir2 again, well, it's just going to overwrite it. But then if we add an I and you press enter, it's going to say, hey, do you want to overwrite it? So we can either do Y or N. We can also move and rename files. This is done using the mv command. So if we ls and we want to move text into dir3, we can do mv text dir3. And if we ls, we see text is gone. And if we ls dir3, we see text exists in there. So let's go ahead and create another text file here. We'll call it text2. If we ls, now say we want to rename it. Well, what we do is we use move, we use text2, and then we give it the name that we want to rename it to. So we'll just call it text new. Now, Linux knows that this isn't a directory that we want to move it into, so it knows that we want to rename the file instead of move it. And if we ls, we see that it has a new name. And again, you can use the -i flag to be safe and not overwrite things accidentally. Finally, we have the remove command, which is rm. So you just do rm and the name of the file that you want to remove. So we can do text new, and we see text new is gone. We can also do this with directories using the -r option. So if we do remove -r, dir1, we see that dir1 is now removed. All right, let's talk about wildcards. So we learned how to remove one or more files by typing their file name out. File 1, file 2, etc. Say we have a folder with 1,000 files. and 100 of them are .html files that we want to delete. Well, obviously we don't want to type out 100 files. We can use wildcards to do this. So let's go ahead and create a few files. So here I've created 4 HTML files. So if we want to delete all these in one go, right, we want to delete everything that ends in .html, but we don't really care what's before it. So what we can do is just type asterisk here. And this is saying I want 0 or more characters followed by a .html. And this is what I want to remove. So if we press enter and we press ls, we see all the HTML files are gone. And this isn't just limited to the remove command. We can use wildcards in any command. Now there are several different types of wildcards that we can use. They get pretty in depth. We're not going to go over all of them. Luckily, the one that you're going to use probably 99% of the time is the asterisk. So we can use it for wildcards that we want at the beginning of the text. We can have something like G asterisk, which is saying that get me all the files that start with a G and then have 0 or more characters followed by it. We can also have something like this where I want everything that starts with a G, has 0 or more characters, and ends in .html. So that's a basic introduction to wildcards. All right, let's talk about hard links and symbolic links. Symbolic links are also known as soft links. So soft links are definitely what are preferred, but you might still run into hard links, so it's good to know what they are and what they do. So with a hard link, you have your original file, and then you have the actual data of that file on the disk. If you create a hard link, it also points to that same data. So if you update something via the hard link, it'll also reflect on the original file. However, the hard link does take up a good amount of space. Soft links, on the other hand, are essentially a shortcut to the original file. However, if you delete the original file, the soft link is now broken. So to create links, we use the ln command. Let's first go ahead and create a file. Let's call it text, and let's create a link from text to our text hard link. Now if we ls using the long format, we see we have text and we have text hard link. These are basically treated as their own file, right? Like I said, deleting one doesn't affect the other one. And as we see here, we have 2 hard links now. Now to create a symbolic link, we use the S flag. So we have text and we have text symbolic link. And now if we ls, we see we have L right here on the left. And here it shows, hey, this text symlink is a link to text or a shortcut. So now if we delete text and we ls, we see text hard link is still fine. However, this is now in red saying, hey, be careful because this text symlink is broken. Next, we're going to take these commands and do some real file manipulation. All right, let's take everything we've learned and put it all together. So let's cd into our home directory. Let's make a directory called playground. We'll cd into playground. Now let's create a couple of directories. So we know we can do that using the mkdir command. And let's make 2 directories. Let's copy a file into this playground directory. So we know we can do that using the cp command. We're going to copy etc password. And to copy it into our current directory, we just use dot. Remember, dot refers to our current working directory. Let's ls. And just for fun, let's try that again, but let's use the verbose option. So as you can see here, it's saying, hey, I'm taking this file right here and I'm pasting it into dot, which is our current directory /password. So if we ls, we see that password is in here. If we want to try it again with the I option, we see that it gives us a check. Do we want to do it? Yes or no? All right, let's do some movements here. So let's move password. Let's not move it, but let's rename it to fun. And let's move fun into dir1. So if we ls dir1, we see fun is in there. Let's move dir1/fun to dir2. So now it's in dir2. And let's move dir2/fun back into our current working directory. All right, let's see the effect of move on directories. So let's move fun back to dir1. And now let's move dir1 into dir2. So if we ls, we only see dir2. And if we ls dir2, we see we have the dir1 directory. Let's move dir1 back to our current working directory. And let's move the dir1/fun file back to our current working directory. All right, let's create some hard links. Before we do that, let's ls, and let's notice that this fun file has one hard link. So let's create fun, and let's create a hard link called funhard. Let's create one in our dir1 directory, and another one in our dir2 directory. So now if we lsl, we see fun has 4 hard links, right? We had 1 before, and then we created 3 more. And remember, Linux sees these as 2 different files, but if we edit one, it'll edit the contents of the other one because they're pointing to the same piece of data on the disk. So how do we know that this is a hard link of this, right? We can say, oh yeah, they're the same size. They have the same amount of hard links, but that doesn't really tell us that it's a hard link. Well, in Linux, there's something called an inode. You can think of it as like a unique identifier for a file. So if we use the li option, we see the first item is the inode number. And as we see here, fun and funhard have the same inode number. So we know that they're hard links of one another. However, there is no way of knowing which one is the original and which one is the hard link. All right, let's create some symbolic links. So we'll do lss fun sim. We'll create one in dir1, and we'll create one in dir2. And remember, for a symbolic link, you need the -s option. So if we ls, let's ls with the long option. So we have this fun sim that points to fun. And first of all, notice it only takes up 3 bytes, so a lot less space than a hard link. And this one only has 1 hard link. And it has the L here to state that it's a symbolic link. So in addition to regular files, you can also have symbolic links to directories. So if we do lns dir1 dir1 sim, we see that dir1 points to, or dir1 sim points to dir1. All right, so finally, let's remove some files and directories. So let's remove funhard. We see funhard is gone, but we see that fun is still there, right? Because it was a hard link. But if we remove fun and we ls, we see that the fun sim link is broken. And that shows because it's highlighted in red. So if we ls and we try to remove, if we remove fun sim and we use the interactive flag, then it's going to say, are you sure you really want to remove it? Yes, we do. All right, finally, let's cd back into our home directory and let's remove playground. But remember, since it's a directory, we have to use the -r flag, and then we can remove playground. In fact, let's just remove everything that we created. And we need to add the -r flag. And I typed dir2 in twice. So what happened here, let's talk about this for a second. So we tried to remove 4 items. So what happened is we removed this item here, we removed this item here, and we removed dir2. But when it got to dir2, it was already removed. So it's saying no such file or directory. So when we try to run this again, these first 3 items, didn't exist. So that's why it's saying no such file or directory for these first 3 items. And then it deleted dir3. So just because it complained about this last item here, it doesn't mean that the entire command failed. These first 3 commands succeeded, so it deleted these, and then it failed on this one. So that's just something to keep in mind. All right, so if this made sense, then this is a huge milestone. I mean, you can pretty much do any type of navigation around your file system. You can manipulate files, create, delete, all that sort of stuff. We did do a lot here, so it might take some time to fully sink in. Just like everything with repetition, it's going to become like second nature. I know the concepts of links can be a little bit confusing, but I think it's worth it to take the time to learn how they work because they can be a lifesaver. In the next lesson, we're going to learn some more commands. So I'll see you then. In this lesson, we're going to learn more about commands. We're going to learn specific commands, and we're even going to learn how to create our own. So in Linux, you can have one of 4 different types of commands. The first is an executable program. So something like ls or anything we see in the user/bin directory. So these can be compiled binaries, programs that were written in C and C++, or programs written in a scripting language like shell or Python. You can have shell built-ins. So these are commands that are built into the shell itself. The cd command, for example, would be one of them. You can have what's called a shell function. Don't worry about that for now. We're going to talk about those in a later chapter. And then finally, we have an alias. So aliases are commands that we define ourselves that are built from other commands. So if we want to know which of these 4 kinds of commands are being used, we can use the type command. So we would type, and then we would type the command that we want. So something like ls is actually an alias to this line right here. So when you're typing ls, it's actually mapping it to ls -- color equals auto. And basically what this does is it just colors your output. You can have type cp. So the cp command is user bin cp. And finally, we can even run type on the type command itself, and we see that type is a shell built-in. And as we see, cd is also a shell built-in. Next, we have the which command. So sometimes you'll have more than one version of an executable installed on your system. So say I have ls typed in multiple places. I want to know when I actually type the ls command, which one of those it's calling. So I can do this with which ls, and we see that ls calls user bin ls. However, this only works for executables. So if we try to do something like which cd, we're not going to get any output. Next, I want to talk about the program's manual page. So if you see a command and you don't know what it does, or you don't know what the options are, we can use the provided manual pages, or man pages for short. So say we want to look at the man page for ls. So here it gives us the name, a description, and it shows us all the possible options we can use. So you can press enter to go down line by line, or space to go down page by page. So for example, that -a option that we were using, we know that it's for showing hidden files. So it says do not ignore entries starting with period. Next, we have the whatis program, and this just displays a 1-line description of a man page. So if we do go whatis ls, we see list directory contents. If we want to do whatis git, and believe it or not, this says the description is the stupid content tracker. And yeah, this is a real thing that someone entered into the man pages. Okay, finally, let's talk about how we can create our own commands using the alias keyword. So in Linux, it's possible to have something like command 1, and then have a semicolon, and then type command 2, semicolon, command 3, and so on. So you can run multiple commands on the same line as long as they're separated by a semicolon. So we could have something like cd user, and then we can ls, and then we can do cd dash. So cd dash just returns to the original directory that we were on. So if we press enter, we see that it's cd'd into user, it printed out the contents of the user directory, and it went back to, right now we're in the user bin directory. So let's create our own command. First, we have to pick a name that doesn't already exist as a command. If we wanted to do something like test, it's not giving us any errors because test is a real command. Now, it's not a good practice to just start typing in and executing random commands. So we can use the type keyword, and then we can write test, and we see that test is a shell built-in. Okay, so we can't use that. What about something like foo? Well, here it's saying foo not found, so we can use that. So to create an alias, we type alias then the name, and then an equal with no spaces, and then 2 single quotes. So then in here, we'll do cd user, semicolon ls, semicolon cd dash. So let's go to our home directory, let's clear it out, and let's type foo. And we see that it prints out the same output. Now, if we want to do type foo, it says foo is alias to cd user ls cd, exactly what we wrote. Now, if you want to remove an alias, you could just do unalias and then the name. If you want to look at all the aliases on your system, you just type alias, and we see all the different aliases, including the one that we just wrote. Now, the one issue here is if we ever close our terminal and open a new terminal and try to type foo, it's going to say command foo not found. So there's a file where all these aliases would go into that would persist through different terminal sessions. And we're going to talk about that in a later lesson. But this is our first step into the world of shell programming. In this lesson, we're going to learn about I/O redirection, or input-output redirection. This allows us to redirect the input and output of commands to and from files, as well as give us the ability to run multiple commands together in what are called pipelines. Before we continue, we do need to talk about standard input, standard output, and standard error. So as we've seen, a lot of the programs that we've ran have produced some kind of output. And there are 2 types of this output. One is the program's results. So if we run ls, this line right here is the output. But we can also have something like an error, where it says no such file or directory. Now remember, the theme of Linux is everything is a file. So when we run the program ls, it's actually sending its results to a file, but it's a special file called standard output, or stdout for short. And standard output is linked to the screen or the console. Same with standard error. Many programs also take input from what's called standard input, which by default is attached to the keyboard. Here's a very useful diagram. So when we type something in from the keyboard, it sends it through this stream called stdin, and that stream is connected to a process or a command. And then that command runs, and if it has any output, it sends it to this stdout stream, which is connected to the display or the console. Or if there's an error, it'll send it to the stderror stream, which is connected to the display. However, we can change where this stream points to. So if this points to a file, instead of writing it to the display, it'll save it in a file. So I/O redirection allows us to change where the output goes and where the input comes from. But by default, the output goes to the screen and input comes from the keyboard. Let's first start by redirecting standard output. Let's run the command lsl and let's print out the contents of user/bin. Okay, and as we see it, it prints it out to the screen. But now what we can do is we use the greater than symbol and we give our file a name. Let's just call it lsoutput.txt. And this is saying, hey, I want you to run this command, but redirect the output from stdout to this file right here. And it knows to create that file. So if we press enter and we ls, we see that this lsoutput.txt has been created. And if we want to take a look at the contents, we see that it's the same results that we just got, but now it's in a file. Okay, now let's try something here. So let's rerun this command, but now let's write to a directory that doesn't exist. And if we press enter, we see, hey, even though we redirected the output to lsoutput, we still got this error printed out to the console. Well, like I mentioned, this line right here got written to stderror, but our redirection was only for stdout. So for that reason, anything that got written to stderror still gets printed on the console. We'll take a look at how to redirect stderror in a minute here, but first let's look at the contents of lsoutput.txt. So we see the file has 0 bytes now, and that's because when we tried to run this command right here, there was nothing written to stdout because this directory didn't exist. So it sent empty text into lsoutput.txt. And when you run this command, even if the file already exists, it'll rewrite it. So you have to be careful with this redirect option. So let's rewrite our file with real data. So let's take a look at lsoutput, and we see that we have the contents back in there. Now, if we want to append to a file instead of overwrite it, what we do is we use two greater than signs. This is saying, hey, if the file doesn't exist, then create it. But if it does exist, don't overwrite it, but just add to it. So say we run this, a couple times, and then we ls output. It's hard to tell because this is such a big file. But say we get towards the end of the file, we see that we're at a Z and then it resets to an A because we appended to the file. And if we want to ls that file, we see that it's a much bigger file now, 250,000 bytes. Let's redirect to standard error. So to do this, let's write to a directory that doesn't exist, and then we're going to redirect to ls error.txt. Now that what we need to change here is before this redirect, we need to type a 2. And the reason for this is each of the streams that you write to, like standard error, standard output, have a specific number assigned to them. So 0 is for standard input, 1 is for standard output, and 2 is for standard error. And these are called file descriptors if you want to get technical. And this is saying redirect, but I want to redirect standard error. So if we run this, we see we don't get any output now. And if we want to look at the contents of ls error, we see that one line that shows the error message. Now, if you want to write both standard output and standard error to the same file, we would type ls bin user ls outputs dot text, and then we'd write 2 greater than and 1. Now, if this syntax looks kind of weird, I agree with you. They did make a simpler way to do this, where you would just simply type an ampersand before the greater than symbol. And if you wanted to append, same thing, you would just have the double greater than sign. Now, if you're someone who forgets, hey, am I supposed to do the greater than sign or the less than sign? Well, one way to think of it is as an arrow. So the arrow goes from left to right. So I'm taking the output of this command and it's going into this file. So from left to right. That's how I like to think of it. That's just what helps me remember. Okay, finally, let's talk about redirecting standard input. Up to now, we haven't used any commands that make use of standard input. So I want to introduce a new command, and that's the cat command. And what this does is it reads one or more files and copies them to standard output. So let's say we want to take ls error.text, and it prints out the contents. Now let's try running cat without any arguments. So we press enter and we see, okay, it didn't prompt us for a new command, but it is waiting for something. So if cat is not given any arguments, it reads from standard input. And like we mentioned, standard input by default is attached to the keyboard. So it's waiting for us to type something and press enter. So let's type keep on coding and press enter. So what it does is it takes our input here, it reads it, and then it prints it to standard output, which is why we get this line right here. And it's going to keep doing this until we hit Control D, which denotes the end of a file. Now, if we want to redirect standard output, we would type cat greater than, and let's just call it cat output.text. Again, it's prompting us to type something, so we'll just say hello. And now, as you can see, it didn't print this line out because we redirected standard output. So what's happening here is we're running the cat command. It's saying, hey, there's no argument here. So I'm assuming you want something from standard input. So we went ahead and typed hello and pressed enter. And now it's saying, okay, since you redirected my standard output, instead of writing to the console, I'm going to write to this file here. So we're going to hit Control D and we're going to cat output, and we see it contains hello. Now let's redirect standard input. So we're going to do cat. Now instead of the greater than symbol, we're going to use the less than symbol, and we're going to type cat output.text. And if we press enter, it prints out hello. So what it's doing here is it's saying, okay, I want to run the cat function. You didn't give me a file, so I'm expecting something from standard input. But since we did this redirection here, we're not using the keyboard for standard input. We're going to be using whatever's in this text file. And remember when I mentioned the arrows, right? So now we're going from right to left. So get the contents from cat output.text, and then std out is going to be the console. So it prints to the console. So I really hope it made sense. If not, you may need to watch it again because this is an important concept. Now that we've covered redirection, let's talk about pipelines, which is a very similar concept. So when we use the redirection operator, we took a command and we sent its output into a file. With pipelines, we take the output of a command and use it as the input of another command. So as we see in this diagram, we have a process or a command running. So let's say it's something like ls. Well, the standard output, it doesn't go to the console, but it gets sent to a pipe, which is like a temporary buffer. And that sends it as the standard input of another process or command. If we wanted to run a command like ls and pipe it, we could do ls, and then we use this pipe operator, and then we type the command that we want the output of ls to go into. So if we press enter here, we see the less program runs with the contents of our directory. So it ran the ls command, and since we piped it, it doesn't send it to the console, but the output of ls gets used as the input of less. Again, if we run that, we see that the less program runs with the contents of ls. Now, before we continue, I did create a couple files. So I created file 1.txt, which has a bunch of items in it. And I also created file 2.txt, which has some more items. We're going to use these two files to demonstrate piping. So we could do something like file 1.txt, file 2.txt, and we can pipe that to the less program. And as we see here, we have the contents of the first file and then the contents of the second file that have been piped to the less program or the less command. Now we can also pipe more than one time in a command. And this is often used a lot for filtering. So say we want to take the contents of these two files and we want to sort them first and then pass them to the less program. So we can use the sort command to do that. So we pipe this output to sort, and then we pipe that output to less. And if we run that, we see that everything is now sorted. So we first run cat with these two files, and we send that output for the input of sort, and then sort does its thing, and then the output of sort is piped to the input of less, and then we see the less command running with everything in sorted order. Now we notice that when we ran this, we get duplicates here, right? We have cherry, we have bread a couple times, we have fish 3 times. So why don't we pipe this into the uniq command? So there's a command called uniq, and it reports or omits repeated lines. How about after our sort, we'll pipe sort's output to the input of uniq and then send that to less. And as we see here, everything's sorted and all the duplicates are removed. Let's say we want to see what the duplicates are. Well, we can also use the options like we normally would in here. So the option to look at the duplicates is -d for the uniq command. Now if we run that, so we get a list of all the items that had duplicates. All right, let's clear that out. The next command that we're going to learn is a very important command, and it's called grep. Grep is used to find text patterns within a file. So you would do something like grep, and then the pattern you're looking for, and then the file name. So let's cat file 1 and file 2. Let's pipe it to sort. Let's pipe it to uniq. And then instead of running less again, we're going to filter that data by using grep. So we'll grep everything that has cherry in it. And if we press enter, we see we have one item with cherry. But let's say we want everything that ends with ERRY. Let's run that. And now we see it shows berry and cherry. So it goes through the input that we give it, and it searches it for anything that matches this argument here. So to better demonstrate it, let me get rid of this grep. So we see everything that uniq outputs, and then let's pipe it to the grep command, and let's do anything that has an E in it. So now it gets filtered with every word in here that contains an E. Finally, I want to talk about the head and tail commands. So sometimes we don't want to get all the output from a command, right? If say we have a massive file and we use cat, it's just going to print that all out to the console and it's going to be hard to read. But let's say we want to read the first few lines of a file or the last few lines. So if we clear that out, so let's run head on file2.txt, and it's kind of hard to tell. So let me cat file2. So we see it goes from berry all the way to corn, but since we're using the head command, it just prints out the first 10 lines. So it only goes up to milk. We can use the -n option if we want to specify how many lines we want to see. So say we just want to see the first 3 lines of file 2, then it just prints out the first 3 lines. Tail is the exact same thing, except it works with the end of the file. So if we want to tail file 2, we see it prints out the last 10 lines. And again, we can use the n option to specify how many lines we want to see. Finally, let's talk about the T command. So T is just used if you want to pipe as well as send to standard output. So we could do something like ls, and we want to send it to, let's just call it temp.text, and we also want to send it to grep. And let's search for anything that has an O in it. So we see grep prints to standard output, but then it also created a file called temp.text that has everything from ls, right? It doesn't just have grep, because grep was run second. So if we wanted to change it up, we could first send to grep, and then we could send to temp.text. And then if we cat temp.text, we see that it only printed from the output of our grep command, since grep was piped first. In this lesson, we're going to learn more about how the shell works. So when you run a command on the shell, there may be some pre-processing that runs before the shell runs your command. For example, when we have an asterisk, this could be a wildcard, and the shell would convert it to whatever it matches. This process is called expansion. So let's take a look at a new command called echo. What echo does is it just takes whatever you type after it and prints it out. Right? So we can do echo hello world, and it prints out hello world. But we can also do echo asterisk. And if you don't know about wildcards, you might just expect it to print an asterisk out. But we see it prints out all the contents in our current working directory. Right? So if we ls, we see that it's the same contents. So what's really happening here is we're typing echo asterisk. Echo has no idea what a wildcard is. But the shell is saying, oh, I know that this asterisk is a wildcard, so I know you want me to do some pattern matching here. So it'll say, okay, let me look at all the current contents of this directory and see what matches an asterisk. And an asterisk by itself matches everything. So it's taking this command and it's replacing asterisk with desktop, documents, downloads, etc., right? And then it's running the echo command. So we could do something like echo anything that starts with a D. So desktop, documents, downloads. We could do echo anything that ends with an S. So this is called path name expansions. We can also do something like echo with the tilde. Now remember, the tilde refers to the home directory. So the shell is saying, okay, I know this means /home/Sam. So let me replace that in here and then run the echo command. The shell also allows for arithmetic expansion. Say we want to echo 2 + 2. Well, if we do 2 + 2, it'll literally print out 2 + 2. Or we can use a $, open and close parentheses, and then another set of open and close parentheses, and then 2 + 2, and then it prints out a 4. The arithmetic operators are addition, subtraction, multiplication, division, modulo, and 2 asterisks for exponents. You can have arithmetic expressions nested within another, so you could do echo 3 times, and then we can have another expression in here that does 2 × 4. And if we run that, we see it takes 2 × 4, which is 8, and then multiplies it by 3. So it takes this inner expression, runs the command, and then replaces it with an 8. And then it runs 3 × 8. That's how we get 24. I'm going to briefly talk about parameter expansion, but we're going to cover it more extensively later. The Linux system has the ability to store small chunks of data and give that data a name. And these are called variables. If you've worked with other programming languages, you should be very familiar with this. For example, there's a variable called user, and it contains your username. Now, if we want to print this out, we type echo, and every variable starts with a $. So we do $, user, and if we print that out, it prints the username, which is Sam. If we want to see a list of all our variables, we can do print env, and let's pipe that to the less command. And as you can see here, it has a bunch of different variables. If we go down, we can see the user variable here equals Sam, and has just a bunch of different settings in here, like our terminal equals xterm 256 color. I believe this is the color scheme that our terminal uses. We see our home directory is /home/sam, and just a bunch of other information the system uses. If you try to echo a variable that doesn't exist, you just get an empty string. Okay, let's talk about command substitution. So this allows you to use the output of a command as an expansion. So if we want to, let's say, echo ls, you can put that in a $sign and surround it with parentheses, and it echoes the ls command. Let's say we want to get information about the cp command, but we forget where it exists. Well, we know with the which command, it'll show us where this exists, right? So say we wanted to get some information about it, we could do ls l, and then we can use command substitution in here, and we get information about the cp command. In older versions of Linux, you might see backticks. So we'll surround the which cp with backticks, and that also works as well. Okay, let's talk about quotes. So say we want to echo, hi, my name is Sam, right? So that works as expected. But say we want to have multiple spaces in between the words. We see the shell removes these extra white spaces before it passes it into the echo command. Another issue is if we want to echo, your total is $50. Well, we see it says your total is $0. And that's because it thinks that this $5 is a variable. And it's saying, okay, this is an undefined variable, so I'm going to print an empty string. So that's why we get this output here. The use of quotations, and specifically double quotes, is how we can have more control over what we want our shell to do. So I created a file that's called myfile.txt. But let's say we want to ls that. We do myfile.txt. Well, it's going to think that these are two different entities. So it's going to say, hey, my doesn't exist as a file or directory, and neither does file.txt. What we can do here is we can put these in double quotes as myfile.txt, and now it knows to treat this as one entity, and we see it prints out the info about the file. The better practice is to not use spaces, but instead use underscores. So let's go ahead and do that right now. So we can do myfile.txt, and we see that you can actually, if you put this in quotes, you can use a tab for autocomplete. And let's just change this to my_file.txt. One thing to note that with parameter expansions, arithmetic expansions, and command substitutions, they still take place within double quotes. So if we wanted to do something like echo user, and we wanted to do 2 + 2, and we want to run the, let's say the date command, we press enter, we see it prints out Sam, it prints out 4, and then it prints out the date. Okay, so going back to the echo command, so say we wanted to keep the spaces in here, we could just put this entire thing in quotes, and the shell knows not to remove these spaces, and it'll print it how we want it. And if we go back to our other example with the $, we can use what's called escaping characters. And how we do this is we use a \, and we let the command know, hey, don't treat this as a command, just treat it as regular text. And if we press enter, we see that it now prints your total is $50. And let's say we wanted to run echo with asterisk, but we don't actually want to run this as a wildcard. Again, we can use a \, and it knows, hey, just print out the asterisk. And let's say for some reason we want to print out \asterisk, we would just use another \. If we print that out, we get \asterisk. So hopefully this lesson removed some mystery and confusion about the shell and gave you a better, proper understanding of expansion. In the next lesson, we're going to learn about one of the most important topics in Linux, and that's permissions. So I'll see you in that lesson. Hey everyone, Sam here. I really hope you enjoyed the tutorial. I just wanted to let you know that this tutorial you've been watching is the first part of my Linux command line course. The full course goes way beyond this tutorial and introduces important concepts that are imperative for becoming competent in Linux. We go more in depth with permissions, processes, the environment, and much more. I'll leave a link below in case you want to check it out. Thank you so much for watching, and I'll see you in the next one.